dot. Okay, we should be live, everybody. Welcome to April 28th, Espresso Talk. Totally different and similar and awesome than Tea Time. I'm going to be the first presenter. Let me transition over to my stuff and share my screen. 1 second. Because of course I closed everything right before I hit live. All right. So I'm going to be presenting on Hermes, which is our mobile service to deliver multiple aggregated feeds, combine them in a list, sort them, and do some kind of fancy stuff. And my tag for it is it's the service that goes faster with increased load. Oh yeah. So firstly, this is kind of like a boring text page. I know, I'm sorry. It's like more than the 4 points a page. But we had this issue where we wanted to get my news. So say, for example, you wanted to have local news, Georgia, and like college sports ball all on one page. We wanted to be able to do that, and we wanted to offer the flexibility for users to check any list that they wanted, of which AJC has 50. So for the method for the back end, there was kind of like a toss-up. Do we want to do JSP, JPT, blah, blah, blah. Anyways, the choices offered would be just far too many for method to cache. It would be ridiculous. So it's like 2 to the 50th power options, a quadrillion. So we could not cache all that. So then we had just a bunch of balances of just speed issues and taking up all the cache and ruining everybody's lives a few weeks ago. We did get into some Akamai caching, which is great and helpful, with props to Jesse Hetty. They have a thing called pre-freshing, where you can set, say, 2 minutes and then like 5%, 10% TTL. It should get it right. Like every couple minutes, Akamai should go on behalf of the users to go fetch that content and put it in cache before another user has a cache miss. So hopefully that's making our users not break cache, but we were still seeing it a little bit. So basically had some issues with method, and we had some slowness issues, and it wasn't quite as flexible. So we decided to take a step back a little bit. We still wanted to abuse Akamai being super duper fast. And of course, I always like doing like stupidly esoteric stuff. So I've been looking at Lambda and the serverless world. I air quoted there, serverless, ha ha ha. But there is a neat option there that we can exploit, where we can pop up as much as we need, as many resources as we need, and it can make the requests on the user's behalf and do all that magic for us. So introducing Hermes, which I totally closed out right before I started this. We authored some stuff to try to do this for us. It's a really tiny project that is documented here. I think I linked my slides somewhere, but I can paste it after as well. You guys should have read access to this, maybe, maybe not. And it's really super simple. Here's the code I already brought up. So we pass a bunch of UUIDs to the service. It parses out all those UUIDs. You can do stuff like how many items do you want returned and the offset. Not as important. That list is passed off to this function. It asynchronously gets all of the items from those UUIDs, and it merges them in a big list. And then the process dedupes and sorts it by content updated, and then does the offset count stuff, and then returns. So this is the whole thing. The whole service is like, let's see, 52 lines. Very short. It's in Python. 52 lines, right? Pretty small. Just did some testing, some stuff like that. So this was what we were kind of specking out. It uses Zappa, which is pretty neat. I don't know if you guys have heard of that, but it's just like a Python framework through which you can easily deploy serverless applications. So here's the current configuration. This is all just on GitHub. You could see if you wanted. You can do a Zappa deploy. Like I think we wrote this. The first iteration was like half an hour. The deploy was 1 minute. 1 minute to push out this whole service. It configured on CloudFront. It configured the logs. It configured Lambda. And it used S3 to upload the package, do all that stuff. and then it changed the API gateway through which you can do like HTTP requests to Lambda. So it's a pretty cool little framework. It did that with just like a couple lines is really all you need, that function in S3 bucket. But since we're fancy and super awesome enterprise, we had to add a few more lines, but it's still really simple. So that's pretty much the service. And there's the code. So I was gonna walk through, I guess, just currently really fast, what we have in terms of like the logs, how it's performing, what it's doing. So I just went to the monitor, so we can see it's not, it's just our mobile apps, right? And it's just one part of our mobile app, so it's not getting hit like a crazy amount. Something like an average of 1,000 invocations per hour, really not a big deal. So it's stuff like, at 3 a.m. and 2 a.m. when there's only 150 hits. It's great that Lambda can spin down all those services, and we're not being charged like hardly at all for any of this time. And then when we hit huge spikes, it can scale up and get like 10 boxes or whatever, according to what we need. We can see that here's the averages are really pretty low and happy for users. And then these other times correspond to when we get uncached method hits. It takes a while to produce those lists, but then hopefully it is cached. And then fun side note, no errors yet, but it's still early and it doesn't get hit a whole lot, so that's not a biggie. Okay, so some other fun stuff. I have a load tool in here. I have some logs. You can really easily access logs via the command line, via Zappa tail prod. So I'll let that go for now. So I have a load balancing tool that I'm going to run. Ooh, I didn't mean to run that one. My bad. So this load balancing tool will hit the menus in different ways. So it can hit it can hit method directly. It can hit the microservice using, Hermes is the microservice. It can hit using one URL. So what that does is when I'm doing my performance measurements, all that stuff, we can make sure that it's cached. We have a lot higher likelihood that it's cached if you run this and it already has all the stuff. So I'm going to see the difference between how fast does it run. Let's see, iterations. I only want 3. I think default is like 20, way too high. So we only want to run against just the stock UIDs here. We're going to run 3 iterations. Oh, it's still pretty fast, actually. Okay, so that time we had a max time of 2 seconds. This is way down here, by the way. So there was one that took 2 seconds. I'm going to run it again. We're on my Mac. Usually I run this on a desktop. But so this one was 1.4. So basically, the more you run it, the faster it gets, down to like a second or so. So everything is sub a second. And then when you get rid of all UIDs, you can just run a crazy load. Okay, so this time, what this test is, now that I tried to cache everything, what we're going to do is hit the service. I think the iterations, let's see. Oh, I have 20 times there, yeah. So it's going to be 20 times however many lists there are available, and it's going to make up new requests. So these requests are UIDs representing a single list. It's going to make a new request that could be like 10 items or more. And it's going to do like a whole bunch. So what you saw count of like 1,000 here, we're going to hit it. We're going to hit it a lot harder. So I'm running it. This is against prod right now. It's scaling for however many instances it needs. I just lost my scrolling. And yeah, so we can see it can handle, in this case, on one machine via Wi-Fi, it could handle almost 2,000 requests a second. It did 240 tests in 7 seconds. And let's just look back here for total invocations. Sometimes it's a little slow. Let me get rid of this. So it kind of naturally does. So you can see one of the things that it's hitting. It adds all these UIDs. These are each lists. So we would have terrible problems caching this and speed. So the JSP and JPT. So where are you going to get this? And we need more information. We just couldn't do it in the JSP because it's too slow. And we needed the information from all of the lists to percolate down. So we couldn't do it all in JPTs either. So we just basically couldn't meet the requirements for method. But here, this is 300 milliseconds. So I'm going to run it again to try to spike it. Sometimes the logs lag behind. What I was really expecting was the invocations would go way up, but they're not brilliant here. So this is everything in the 2 o'clock hour. Well, it's a lot higher. So we'll see. I'll just run this a couple more times. And we should see it spike up. So what's happening is all these machines, potentially, if the need is there, are spinning up because there's like 8 threads asking simultaneously for stuff. So yeah, so this is a little higher. And we don't have to do any machine maintenance or like all that sysadmin stuff because these machines live for us, as far as we care, the machines live only as long as the request is active, and then they die. It's like a meseek. It's up, it does its job, and it's done forever. And we will never have to care about it. So yeah, that's about it. Let's see, do I have anything else? Oh yeah, we're gonna do Redis someday, maybe not. Take advantage of some sort of other caching mechanism because Method is kind of on the slow side sometimes in that uncached case. So this would mean that we would never get uncached lists ever. So something like every 5 minutes, just continuously update all the Redis lists all the time. So yeah, I think that would help a lot. But yeah, that's the gist of it. Does anybody have any questions? Yeah, we can see it's lagging a little bit behind because we probably got to like 3,000 requests or so. Just in like.
Very nice, man. Thanks.
All right, great. I'll stop presenting. I'll wait like 5 seconds for whoever wants next, and then Alan, are you gonna present next? Yeah, so I saw Claudio. So you saw the GraphQL note, right? So someday maybe we're gonna get GraphQL. We won't need any of this stuff, but that's why it's nice that it's so tiny, 50 lines. We can just dump it. We get GraphQL, it's gone. We have that flexibility since it's small.
It was weird hearing you talking about caching because every time I bring that up, I get, but no, don't add another layer of caching. And I'm like, we need that. We need it. And everybody's, but the complexity smishes, damn it. But yeah, I like it. It's pretty sweet. I never heard of Zappa before. I like that.
Yeah, it's cool. I think the more popular one is probably the serverless, so JavaScript. This also existed as a serverless project, but it wasn't as complete. So, yep. Well, cool, thanks. Alan or Dan, are you guys ready?
Yeah, I could go. Let me start sharing my screen. And let me know when you can see this.
Yes, I see a hangout.
Cool deal. So today I just wanted to talk about something that I found personally very handy in my web development. I don't have any slides. I was just going to show some demonstrations on what I do. It's just using, and many of you probably have done this before, but using regular expressions when working with the files and how that helps work with the file better. This isn't to say what you should do, it's just to tell you what you could do using this. And probably a lot are already familiar with regular expressions, and there are plenty of sites to talk about this, regexer and other test sites, and you can do your own test right here. I found it helpful to start with the basics. Like if you look at this, whole thing, it's pretty confusing, but if you start with something small and then start building up, then you can then you actually understand what you're doing. But basically, well, let me go into a demonstration and show you what you can do with this. And I'm using all files that are from our current live site. Like this is HTML and XML that I get from our site. But so you just start up the search and replace, and I'm going to use Sublime Text, by the way, and probably other text editors will allow you to do the same thing. But you have to click this dot asterisk to turn on regular expressions. So for instance, this is what I do. I noticed, like, one of the things I had to do the other day is to check the pub date. and to compare this. And the way it's output on our site, it's really hard to do because of these large spaces. So I just use a few lines of regular expressions, and it substantially speeds it up. For instance, I can actually read what's in the text. So one thing that I can do is just use like \n, which is the end of a line, \s star, and that would select all the white space in between, and then close it off with that, and do let's see, replace with another line, and that gets rid of all the white space. And then what I do is I just do this expression right here, which it selects every line except for the pub date, because this is what I wanted to compare, and replace it with nothing. And it will get rid of that. And also one more. Let's see, this, I've already done these ahead of time. I'm just showing what you could do with this. And then there's this one right here you can just get rid of. So this allows me to quickly look at this and see if the XML list is in the correct order, because we had some problems the other day when we couldn't tell if it was being output correctly. So stuff like this is what I use it for, just to format the text. And sometimes I use it to actually change the text and save it. But a lot of times it's just to examine the code and see what needs to be done. So there's other stuff you can use it for, like, for instance, you can trim the end of a line. Like if you use this regular expression right here, this is basically, and it looks like it's already trimmed, but you can do stuff like use I forget what this character is called, the caret, and then this, and that trims the beginning of the line. You can do other things like get rid of all the classes, for instance. And I'll show you straight in here what you can do. Like if you want to get rid of all of the classes in your HTML, then you could do that. And you could see an example right here. And just replace it with nothing, and it gets rid of all the classes. I'm not sure why you would want to do that, but just to show what's possible with this. You could replace, like for instance, if you have a JPT file, and you want to replace the code, you can use this to replace it with the JSTL comments. Another thing you could do, like for instance, I've seen this quite a bit. There's this badly formed code. You can, I'll show you how to do this live. Like for instance, take the end of a tag. Let's see. About this. So here's an example, and it's kind of hard to read with this. So what I'm doing is finding the end of a tag and doing this as a capture group. So what this is the space is a literal space. So it finds all the literal spaces, and the plus means one or more instances of this. So it selects all of this, and what I want to do is to give it its own line. So I do this replacement right here. And what it does is it selects the end, makes a new line. The /1, the \1 is a reference to whatever's in here, which is the space. And so when I do that, it now looks a little prettier. So again, some stuff you can do with regular expressions. Another thing, interesting thing, like if you have CSS, for instance, you want to take your CSS and replace all the long forms and make it short. Like what I want to do is select, this is a capture group. So what I do is select any character from A through, is it H? And then 0 through 9. So that's the hex characters that you have in here. And then what I want to do is, this is a back reference. So if it repeats itself 5 times, then I select that and I replace it with, let me see, replace it with its 3-character equivalent. So it would just make it shorter, like this. So it's just a way to do this. Now you could also do a more difficult, complex version right here. No, here it is. And this does like AA1144. If you do something like that, this would make it its 3-character equivalent. So it also works with the 6-character versions. And so the AA1144 and 998877 would change to the shorter version, like that. So this is stuff that you can do in CSS, and it shouldn't have any adverse effect. But again, I'm not saying you should do this. I'm just showing what you can do with the regular expressions. And there's also other things like, this is a pretty neat one if I can remember how to do this. Sorry about that doorbell there. So this selects, so I forgot to put in the WebKit transform here. So what I want to do is select the line that has transform, and I want to add a couple of more lines which have the WebKit transform and the O transform. And so this is what it does. It actually generates that based on a regular expression replacement. And then you could do other things like you want to replace this with a tab like this. And so you could do that, and it replaces it with a tab. Hold on just a minute. I got the doorbell ringing. Sorry about that. Well, anyway, there any more questions about what you can do with this? Does everybody know what this is used for? Has anybody done this before themselves?
I've done that. We're going to get this file. This file is pure gold.
What's that again?
I've done very little of this. I've done the space replacing, but could we get a copy of this file? Because this file has a lot of great stuff. Yeah,
I mean, you could do a lot of things with this. Like, for instance, you want to remove the comment. I'll put out a comment. I'll put this out on the link to this Hangout. But you can also do other things like remove comments. I mean, I put all kinds of examples in here. So all you have to do is do this, and it removes it like that. But there's another thing that's really interesting about this is you notice the question mark right here. That's the, I think it's called the lazy selector. So this is the greedy selector. So what it does is it selects the beginning slash, and you have to escape the asterisk. And then any character in between up into this, it selects it. But since there's a character to the end, it selects the whole thing. So what the lazy selector does, it only selects it up to the, it only selects it up to here, and then it isn't greedy, and it doesn't select it up to the end. Another thing you can notice is the, this one right here. This is the negative look ahead. So what happens here is this question mark bang, it would exclude this. And then it would look for anything after this, but it would exclude this pub date. And you can do other things like a pipe, which would, sorry about that, noise here. So let me show you what this does. it would, okay, so you see it doesn't select this. Now if I add something else here, like the I can't even remember what the name of this is, the pipe, then you could add other things like it shouldn't start with link, so it would exclude link as well. And so you would leave link and pub date. So this is just really good for like looking at a file if you want to find something in a file, or if you know you can replace something, then it's really good for that. So it's just, I find it really helpful. Has anybody else used this kind of thing in their code?
Yeah, I use it a lot, but sometimes I get too involved with the regex, and I realize that just going by hand and pasting like 3 appearances of something would have taken 2 minutes, but I end up spending like 10 minutes trying to play around with the regex. But it's sometimes too much fun to play around because there's so much you can do with it.
Yeah, it's really powerful. You can do a whole lot with this,
By the way, I don't know if people have used it, but in Eclipse, we can do that with all the JPTs that we do. Although I'm not sure if you can replace, I haven't done that. But yeah. Searching, you can definitely search using regular expressions.
Yeah, sorry about that. Couldn't get to the mute. So I guess, yeah, that's about all I had. There's just a bunch of examples in here, and I'll put the file out if anybody wants it. But I find it really helpful. So, like, you can do stuff like this, like you want to replace these comments with another type of comment. Like, you can replace it with a multi-line JavaScript comment or something like that. But yeah, you can do a lot with it. But anyway, that's pretty much all I had. I just wanted to show a little bit of how I use it. Who was next? Was it Dan?
Yeah. Thanks so much, Alan.
Thanks, Alan.
Dan, take it away.
Okay. Yeah, that was cool, Alan. I personally haven't used that to that degree, but if you have a bunch of data to edit, I see how that would be useful. Okay, so it looks like we got about 15 minutes. So I'm going to go ahead and I'll probably just talk about the event queue stuff, and then maybe at another Talk or what do we call them? Espresso Talk, then we can talk about the other thing I was signed up for. So I'm going to talk about, from a very high level, how work gets done in the page. And the reason why I'm going to bring this up is because from a performance side, we actually have the ability to eliminate almost all of our jank frames. So a jank frame is you load up the page and it just sits there. You can't scroll. It looks like stuff is blocked. It's a total UI freeze. So this, what I have right here in front of us is like the most simple, dumbed down version of this, but I think it'll work really well for explanation purposes. But just keep in the back of your mind, there is a whole lot more of this. For example, I'm not going to talk about micro tasks. I'm not going to talk about the other queues that are out there. But for the purposes of writing our code day to day, I think you'll hopefully find this useful. So I'll start at the top. The single event loop thread, each window in your browser. Well, actually, let me back up. So you may have heard the phrase JavaScript is single threaded. So what that means is that in each of your windows, you've got an event loop thread, and it sits there and it does work. Now the browser decides what's being worked on. So there's, like I said, I'm not going to dive into a ton of the micro details, but this decision point here changes based on the browser. And in fact, sometimes it's not even super clear how these decisions are made, or it changes version to version. But the point is, the browser is going to pick a piece of work and feed it to be processed. So okay, so then down here at the bottom, I've got the 3 queues. So there's actually more than this, but just for this talking purposes, we've got the user inputs. These have high priority. So that, for example, scroll events, so I want to scroll on the page, typing, clicking, that stuff gets prioritized. Then next we have the website code. So this is the stuff that we write typically. This is just normal. Task is actually a jargon, but for this purpose, just think of everything under the broad description of task, and that just means it's a single piece of work. So like if I had a program, it would be like one line in the program, like console.log. That would get queued as a task. And like it says here, it just gets executed as queued. There's no special priority given to this. And then the final queue that I'm going to talk about is the animation queue. And this is where things end up when you use request animation frame, or RAF or RAF. And it's its own queue. But the important thing to think about is, just because it's in its own queue doesn't mean it's executing separately. The browser, it's still single threaded, and the browser is going to pick where it pulls from. It's just something to keep in mind, that it's in its own queue. Now this one is prioritized because you want things in that queue want to get executed before the next repaint, or at least it's going to try the best it can. So what that means is as this fills up, you start seeing lower frame rate. But I mean, I suppose that's true for any of them, but this one especially, like as it gets to the end of the frame, it'll start prioritizing stuff in here higher. And there's one last thing I want to mention, and that is, when something is being executed, that means nothing else is being executed. It's not rendering, it's not accepting inputs, it's not doing anything except that task that it's working on. So just because this, my console.log statement may be a lower priority, it doesn't mean it's not blocking other stuff in the browser. So to phrase that another way, console.log may be the lower priority than, say, a keyboard input. But if I'm already up here doing the console.log, the keyboard input doesn't matter, because it's not going to happen. Okay, so that's like the bird's eye view. That's the bird's eye view for the bird's eye view. So next, I want to talk about. Oh yeah, this is just sort of to reiterate what I was talking about. It's a queue. It enters in the bottom, leaves at the top. The browser selects, and then it gets stuck up here for execution. Actually, there's one other thing I want to say before moving on. This executes completely. So it's not like, for example, in an operating system's code, it plays games with like partial executions. That doesn't happen in JavaScript. That doesn't happen in your browser. It'd be cool, but it doesn't. So what that means is that whatever this task is, it will run to completion before it frees up a room here, a spot here for the browser to fill. So knowing that, I have a demo set up. And so I'm going to move over to this tab. And let me talk a little bit about what's going on here. So it's just a text with a bunch of filler, or a page with a bunch of filler text. I have this little animation going just for something to look at. And then for logging purposes, this is, it says done in so many milliseconds. And what I'm referring to is this. So we're going to do complicated stuff is going to be our abstraction for whatever we're doing. Maybe that's loading a video player, maybe that's recording metric, maybe that's displaying an ad, loading the rotator, photo gallery. We're just going to sort of push that into a black box and say that that's do complicated stuff. I have these values set up. If you're really curious about how this demo is set up, basically the setup is we have an array of 100,000, and we're going to do 400 multiplication or aggregated multiplications on every entry in the array. So 400. Well, I don't know what the cross product is, but you get my point. Okay, so now we're going to get to the actual demo. So we know do complicated stuff is our abstraction, and this setup might be an app that we write for a ticket. So we get a ticket, and it's like, here's one example is load videos in the page. I'm going to bring up videos a lot because I've been working with it. But say we had 5 videos in the page. So it's in a queue, and we want to load them all. This right here is very simple. It's a for each, and it just goes one by one, nothing special. So this might be the starting point of your ticket. Now, if you're wondering what this is just a debounce, because I have it hooked onto the scroll event just for explanation purposes. It could be bound to anything, but it's just so that I can do it over and over again without mashing the keyboard. But yeah, so this is just a debounce, and and then start here is just recording the timestamp for performance timing, so I can, that's how we get the 800 milliseconds. And then all we do is just process. So now let's see how this runs. Uh-oh. So we have a problem here. We're loading our videos. That's pretty fast, less than a second, but hopefully that's showing. Look, we just totally janked the page up. This is like minimum 1 jank frame. We probably have more, but as you can see, this is not going to work. So this is not acceptable code. So what do we do about it? Knowing that whatever's up here is stuck executing to completion. Well, it turns out that there's a way to simulate partial execution. And what we can do is we can use set timeout 0. So what that does, now it's actually, even though it says 0, it's actually not 0 milliseconds. There's a minimum fidelity for all timing, and every browser is different. Chrome, I think, is 4 milliseconds, but it doesn't really matter because the effect is the same. What it does is it will pull it out of current execution and re-queue it. So if you can see here, now B is ready. It's sitting there waiting for the browser to pluck it, then C, and we've just re-queued A. So let's take a look at what that might look like from a code standpoint. Okay, so we know we want to break it into smaller chunks. So I'm just going to replace this here real quick. And what did we do? So we're still just coming in, timestamp, process the queue, except now what we're doing is we're saying smaller chunks. So we're going to do 6 of do complicated stuff. Instead of the whole array, we're only doing a 1/6 of it. And then we're going to recurse. And if we're done with the queue, then we're going to get a final timestamp and output our logs and stuff. But N0s is just starting over. So this is basically, the mentality would be, I'm only doing a 1/6 at a time. So it should run faster, right? I mean, that's what we've learned in school, and what we learned everywhere is divide and conquer. Okay, so let's divide it into a 1/6. Nope, that didn't get it. Still runs like crap. Damn, why did that happen? Well, if we look at back to our model, remember when we said this runs to completion? It doesn't matter what else is waiting. It doesn't matter if there's UI or anything else waiting. This runs to completion, end of story. So what did we do in this code? We just recursed. We didn't re-queue at all. So we just called process queue again. Well, that's no different than the code we had before. We literally accomplished nothing. So how do we re-queue our task? And it turns out it's very simple. All we have to do is set timeout 0. So we're going to come in. We're going to do our complicated stuff. Fine. And when we recurse, look what we hit. We hit a re-queue event. So that's going to pull it out of current execution and re-queue it in the website code. Okay, so let's see how that runs. Ooh, we're getting smoother. And if you notice, we're still accomplishing the same amount of work. We're just not destroying the page. So it's really a win-win. Okay, so it's getting smoother, but it's not that good. So then we can enter our request animation frame. So what this means is instead of just going gung-ho and saying, oh wait, no, sorry, that's the next example. I got ahead of myself. Okay, so what if we replace set timeout 0 with request animation frame? Remember, we said over here that it's a separate queue. So what if we, instead of re-queuing back here onto this big thing, we use the second queue? Well, it turns out, because of how request animation works, I hope that's coming through in the video, but it's not running very well. It's much slower than set timeout 0. So why is that? Why is request animation frame so much worse than set timeout 0? And it's because of what the queue is meant for. It's meant to be executed before the next repaint. So that means we're going to try and execute according to get that everything wants 60 FPS. So we're going to try and prioritize it. So what that means is that even though it's really not a good idea to run it, it gets higher priority because of it, as it nears the end of the frame. So it's basically going to try and cram more of them in there. So it's actually moving backwards. So that's why that runs worse. Okay, so now we get to what I was talking about before. And this says, okay, so we know set timeout 0 is what we want. So now what happens if we do a 20th? So a 6th was good. Maybe a 20th is better. Let's find out. Oh, baby. That is smooth. Look at that. Nothing. You can't even tell. So we're accomplishing the same amount of work, 0 impact to the end user. We're accomplishing 400 multiplication on an array of 100,000. As you saw earlier, we were probably getting like 4 FPS before. We're smooth.
Hey, Dan, one question. I noticed that it's taking longer for the task to be accomplished, right? That's a byproduct of the doing this, right?
Yeah, that's a good observation. That I was going to bring that up at the end. So the argument here is I don't need to change the whole world at once. I can do it little bit at a time. And I would be hard pressed to find an example where you know, an extra 200 milliseconds in this case, just in this specific example, would make a difference. So we're accomplishing the same amount of work, no impact to the end user, and it only cost us about 200 additional milliseconds to process that task to completion. So, but yeah, that's a very good observation. It's definitely something that deserves to be talked about because it's all in consideration, right? So if you're working on something and maybe the business says, "Why is this so slow?" You know, maybe you need to reevaluate the solution. But if you did notice, this is a 20th, and at a 6th, we were. Well, here, I'll just change it for you. So you can find. My point is, you can fine-tune this to find a solution that works, right? You don't need to bulldog the web page because there's just better alternatives. Okay, so now this is the final point I want to make, and that is, what would happen if we tried to tie it to the frame rate? So what if we use request animation frame let me go back to this. Request animation frame, enters it into that queue, animation queue, because it's attached to the scroll event, so seems logical. But this is going to queue the initiation of the task, meaning it'll start execution here, re-queue here. Remember, we don't want to re-queue here because the way this works. We want to re-queue here, but we kind of do want to start here. So let's see how that looks. And I hope that shows through in the video. I hope it's not janky, because in person, you literally cannot see a difference. There is no jerkiness to the scrolling at all. And also another thing related to this timing here is the scroll event is a very greedy event. It actually fires multiple times in rapid succession, which is why I debounced it. So in normal work, you wouldn't see this. I mean, the variation is crazy. So if I scroll fast, we're like 1700, but if I scroll slow, you know, we're at 800-900. So you wouldn't. The only reason for that variation is because I tied it to the scroll event because I'm lazy and don't want to push keys. But yeah, okay. So well, unfortunately, I'm 5 minutes over, but hopefully that was useful. I mean, it can apply in so many places, divide and conquer, and then using this trick and a knowledge of how work gets done. I mean, you can Tai Lopez this thing with the knowledge. So that's it. Hope you guys like that. Isn't so smooth. Oh, that sucks. Yeah, I was worried about because the video, the whole streaming thing.
Yeah, thanks so much, Dan. That was awesome. Thanks
thank you.
everyone for the great presentations. And John, thanks for saving the talks. I wasn't able to get the Hangouts on air. And this is probably going to be recorded, right?
Thanks, everybody.
Yeah,
Good
so
stuff.
this is recorded. We can always go back to it and if we ever need to. I'll provide the link where all the talks from before and this one will be. And all right, thanks everyone. Okay, bye.
Thanks, everybody.
Thanks. Bye.